day, awesome people. This video that I'm recording, yeah, it's done with the intention so that you can revise the work and go through it, in your own time. And when it, of course, because we don't always have the time to meet up at, and plus logistics of driving, far and all of that. And the other thing is, I know that some of our members have decided to continue with 874 next year. So another reason why I thought a video, I'm trying to think, recording of the statistics would be more ideal, is because then those are going to continue 874 next year. They can go through the work in the meantime and prepare, use the videos to prepare and all of that. So yeah, like I say, so that's the whole reason behind recording this. And yeah, it's just more convenient for all of us. So yeah, and the thing is, I'd like to show something to all of you, because I know sometimes I get the impression, okay, I'm seen as the clever guy in class or whatever. But the thing is, because I understand stats, I'm not a guru at it. I mean, the thing is, like I said in class once, I go through the work time and time again. The practice is all that there is to it. So in any case, I'm not going to have a Dr. Full talk, but I'd like to show you my statistics marks from the first time that I tried statistics. This was statistics 111, the most basic form of statistics. Okay, so where's Chilius? There's Chilius. So let's quickly look at what each of these marks represent. Okay, so test 1, test 2, semester test, and then these were online tests on Ifundi. Okay, so test 1, 2, semester test. Go down. Okay, test 1, I got 47%. Class test 2, so this is class test 1. Like I said, I got 47%. As you can see, class test 2, I got 24%. The semester test, I got 25%. And then I'm sure each of you can imagine, oh, okay, I didn't even bother. I was like, oh, whatever, I'm not even going to do the Ifundi tests. So I just left it. So like I say, this is me. Look at these marks. Now the thing is, so like I say, I just tried that the evidence is right there. I didn't just get it straight away. All that I did is I tried, and after a while it started to get to me. So, I mean, sink into my mind, and I started to grasp the concepts. So like I said, I'd just like to show that, because I presume that there are some of you who question, can I do this? Don't talk to yourselves like that. So in any case, there you see it for yourself. Those were my marks the first time I tried stats. And over here it is, I'm busy, recording a video to help all of you to go through the work. So the first thing we're going to go through is correlation. Now, correlation, what are the key words that a person notices if they break them up? What I see co and relation. Okay, so co is two or more. For example, cooperation, correspondence, there are two or more parties involved. And relation, what is relation? Let's see the synonyms, for example. Well, over here they say family, next of kin, all of that. But the way I see it is, if there's a relationship between two things, they influence each other. So therefore, in correlation, we're looking at two variables, and we're looking at how they influence each other. So now, in terms of this plot, I'm going to show you, just the basic graphical illustration of what they're talking about in correlation and where it comes from. But I don't think that these graphs are actually going to be included in, the articles. No, they're just going to show correlation coefficients, but we'll get to that just now. So now, over here, we had a study, and we were investigating, as you can see, marks in relation to the hour study. We want to see, does a relationship exist between the amount of hours studied and the mark that a person gets. So for example, in this case, I am a life science teacher, so to speak. So now I noticed, I gathered data about, let's say I took 5 kids. Now, how many are there here? 1, 2, 3, 4, 5. Yes, 5. Okay, so I have a class of 20 children. Okay, so I randomly went to 5 kids, and I said, okay, what was your mark? And I wrote down, okay, one of the kids got 35% and he only studied for an hour. Then I went to another kid and he got 75% and he studied for 4 hours. Then another kid got 60% and he studied for 3 hours. This kid got 45%, he studied for 2 hours an hour. This kid got 80% and he studied for 5 hours. Now, have you noticed that as the amount of hours that were studied by a person or one of the kids increases, so does their mark. So therefore, as the count on this variable, hours studied, increases, so does the count on marks obtained. So therefore, a positive linear relationship exists between these two factors. Now, the first thing that indicates it's a positive linear relationship is because look how it's pointing upward, okay? So it progresses, that's a positive relationship. So like I was saying, so therefore a positive linear relationship exists between us. Now have you noticed how the variables are quite concentrated in a line over here? You'll see, okay? Now the whole point over here is that a linear relationship exists between the variables. That's the thing we want to, one of the first things we want to see in terms of correlation, we want to see if a linear relationship exists between the variables. Because if a person can see over here, if you have to draw a line, you know, there is like, it does resemble a line, the pattern over here. So, okay, and then now the correlation coefficient is a certain number that is given, and that number indicates the type of the relationship and the strength of the relationship. So over here in statistics, R denotes the correlation coefficient. So this is the number that will indicate the strength and the type of relationship between hours studied and marks obtained. So okay, I'll quickly go to one of the stats slides from when we went through this stuff. Okay, now different relationships, we'll get to that now. Okay, so the correlation coefficient. Now, if the correlation coefficient is a plus, so there's no negative in front of this, so therefore it's a plus. If it's a plus, it insists that there's a positive linear relationship, okay? Whereas if it has to be negative, it'll indicate that if a negative sign, let me rephrase it, sorry, if a negative sign is in front of the correlation coefficient, that'll indicate that the relationship between the variables that are being studied is a negative linear relationship, but we'll get to a negative linear relationship now. So looking at these comments again, okay, a correlation coefficient that equals 1 would indicate that a perfect positive linear relationship exists between the variables. So therefore this is about 0.9, and as you can see it is quite close to a perfect line, but it is not a perfect line. Moving on to the negative 1, that would indicate a perfectly negative linear relationship. A correlation coefficient of 0 would indicate that no linear relationship exists between the variables. Okay, so those are the main comments that we are concerned about. So now in terms of linear relationships, okay, different relationships. Okay, so over here, this is a strong positive linear relationship. Now, why do we say it's a strong positive linear relationship? Okay, firstly, it's positive because it progresses upwards. As the count of the variables on x increases, so does the count of the variables on axis y. Okay, x-axis, y-axis. Okay, so, and the reason we say it's strong is because look how closely concentrated these variables are along the line. So for example, over here, a weaker positive linear relationship, can you see we can still draw a line through and it's progressing upwards, but the variables are not that concentrated towards the line. So therefore it's not a strong positive linear relationship, and in such a case, yeah, the correlation coefficient would be equal to about, I'd say, 0.5, whereas in this case it's about 0.9. So now moving on to the negative linear relationship. Okay, so in case any thoughts are hanging on your mind, I'll just go through the stuff again, and I hope that I'll address any questions that are pondering. Okay, so correlation, like we said, when we investigate correlation, we're looking at the linear relationship between variables. We want to see if a linear relationship exists. So over here, this is an example of the counts between the variables. Okay, the counts between the variables, as we notice, as hours of studied increases, so do the marks that are obtained. So therefore, progress, positive progress in the variable on the x-axis time will lead to positive progress of the variable on axis y. So like we said, the more hours are invested towards the studying, the higher the marks tend to be. So therefore, an increase in hours studied will lead to an increase in the marks obtained. Okay, so like I said, positive linear relationship. Now this, like we said, is the correlation coefficient. That is a number, and when we look at that number, we should immediately be able to tell the type of the relationship. Is it a positive or negative relationship? And whenever we talk about correlation, we're referring to a linear relationship, like we said, okay? So therefore, 0.9, it is not a negative in front of the number, so therefore it's a positive relationship. And 0.9 is a strong linear relationship. Okay, so like we said over here, strong positive linear relationship, positive linear relationship. Now, this is an example of where no linear relationship exists between the variables. So now going on to the negative linear relationship. Okay, so in this study, we were interested about the amount, we wanted to see if smoking influences an individual's lung capacity. So now we went to, let's say we randomly walked up to 5 people, and then we asked them, okay, how many cigarettes do you smoke per day? Obviously we saw smokers. We walked up to them, we asked, okay, how many cigarettes do you smoke per day? Then we asked them to blow into one of those things, I don't know what you call them, but it looks like a breathalyzer, and then it measures a person's lung capacity. Okay, so we did that in our investigation. So we went to one individual, and now we saw him standing with a bunch of smokers. So we went to him like, okay, how many cigarettes do you smoke per day? He said, no, I do not smoke any cigarettes. So look over there, near amount of cigarettes smoked per day. He said 0. He said he doesn't smoke, so we entered 0 there. We tested his lung capacity, and his lung capacity is equal to 2 liters. We went to another individual, and we asked him, okay, how many cigarettes do you smoke per day? He said, I smoke 10 cigarettes. So then we asked him if we can measure his lung capacity. He said, yes, it's fine. We measured his lung capacity. His lung capacity is equal to 1.1 liters. We went to another individual. They smoke 4 cigarettes per day, and their lung capacity is equal to 1.6 liters. We went to another individual who smokes 14 cigarettes per day, and we found his lung capacity was equal to 0.8 liters. And then, yeah, I don't know if I've mentioned this one yet, but okay, an individual, we found a lady who smoked 4 cigarettes per day. Her lung capacity was equal to 1.6 liters. So have you noticed that as the amount of cigarettes, okay, as the amount of cigarettes that a person smokes per day decreases, they tend to have a higher lung capacity. So therefore, as the amount of cigarettes that a person smokes increases, we found the lung capacity decreases. So therefore, this is a negative relationship, since as the progress in one variable increases, the progress in the other variable will decrease. Because the thing that really allowed me to grasp the concept about a negative linear relationship was I thought about it, because I'll be honest, I'll just say dead straight. I was chilling with another girl, and whenever I was, spontaneous, she had just become negative. And whenever I was down, she felt happy or something like that. So, okay, I'm not trying to get all Dr. Phil here, but the whole point was that as progress in the one increased, the, positive state of the other would decrease. So therefore, your negative relationship like I said over here, so for example, as the count along the x-axis increases, the count along the y-axis decreases. So for example, over here we've got 4 cigarettes per day. They have a lung capacity of 1.6 liters. Over here, this person smokes more cigarettes and they have a lower lung capacity. This person smokes even more cigarettes and they have an even lower lung capacity. So as the amount of cigarettes increases, the lung capacity decreases. So like I said, the main point, as the one increases, the other decreases. So that's what we mean by a negative linear relationship. So now in the case of a negative linear relationship, a negative symbol will be present in front of the correlation coefficient, okay? So like we say over here, it's a negative 0.9. So 0.9 tells us that there's a very strong linear relationship between these variables. And like I said, the minus sign in front of the correlation coefficient tells us that it's a negative linear relationship. So a negative linear relationship will always progress downwards like this. So if we look over here, this is an example of a strong negative linear relationship. This is a weaker negative linear relationship. Okay, so this would have a correlation coefficient of, I'd say, about negative 0.5. So yeah, like I said, 0.9 over here. So if we see 0.9, we negative 0.9 here, we know that it's a strong negative linear relationship. Okay, so I hope that the point is, yeah, that I've conveyed the whole point and concept of correlation to you well, that you understand it. I hope that's the case. So now I got a definition of correlation coefficient, and yeah, I basically paraphrased it in my own words. So a correlation coefficient is a numerical value. So here we've got a numerical value that ranges between -1 and +1. So a correlation coefficient can be between -1 and +1. And a correlation coefficient over here we say indicates that the nature of the relationship, and this refers to whether it's a positive or negative relationship, and the strength of the relationship between two variables. And like I'll ask you, what will indicate the strength of the relationship? The numerical value, okay? So if it's 0.9, it's very, very strong. The variables are quite concentrated in a linear fashion. If it's a lower correlation coefficient, the variables won't be as concentrated in a linear fashion. So for example here. So okay, now that is the correlation coefficient. So then on the other hand, there is the correlation matrix. Now the correlation matrix is what we see in our articles. So this is a correlation matrix over here. Né? So what the correlation matrix does is it just basically tabulates or tabulates, sorry, wrong word, it tabulates the correlation coefficients between the variables, and it basically just summarizes them. So by tabulate, I mean it puts them into a table. So over here, if we look at job satisfaction, okay, job satisfaction, and now over here we want to look at job resources. Okay, so job satisfaction, oh, okay, job resources intercepts job satisfaction over here. So this will indicate the correlation coefficient between job satisfaction and job resources. So okay, firstly over here, I will ask you what, for interest's sake, just so that the words can sink in, what type of relationship exists between job satisfaction and job resources? Is it a positive or a negative linear relationship? If you said a positive linear relationship, you're correct. Why do we know it's positive? Because, excuse me, because there's a negative sign is not present in front of the correlation coefficient. Okay, so let's look at emotional well-being and job satisfaction. Okay, what is the relationship between emotional well-being and job satisfaction? Okay, Now I'll ask you, where does emotional well-being intercept job satisfaction? Okay, let's look at emotional well-being's column. Let's go. Okay, here it intercepts job satisfaction. Okay, so what is that correlation coefficient? Yes, it's 0.5. Well done. Okay, so now, is that a positive or a negative linear relationship? Yes, it's a positive linear relationship. How do we know that? Because a negative sign is not present in front of the correlation coefficient. So now let's look at the relationship, and I beg your pardon, I should have entered a negative sign over here in front of all of these. But I see that I'm doing so now. Okay, so now we want to look at the relationship between burnout and job satisfaction. Okay, so burnout's over here. Let's make it blue. Okay, now where does burnout intercept job satisfaction? Okay, burnout, where does it intercept job satisfaction? Okay, right over there. Okay, so now what type of relationship is that? Yes, it's a negative linear relationship. Now, what does a negative linear relationship mean again? As burnout increases, job satisfaction will decrease, because remember we said in a negative linear relationship, as the one variable increases, the other variable will decrease. And as we can see over here, a negative linear relationship progresses downwards like that. Okay, so now, like you can see, the whole point of a correlation matrix is to summarize all of the correlation coefficients into one table. But now, have you noticed how over here these values mirror each other, such as the correlation between job satisfaction and job resources is mentioned over here and over here. And have you noticed a perfect one over here, like there's a, and it just progresses in this fashion. Now the reason behind that is that obviously job resources perfectly resemble job resources, so their correlation will be perfect, it'll be 1. So that's why the one progresses down like that. So that's why a lot of the time a research in an article, they will just place a dash like that in front of the where the two variables or the same variable, where it intercepts itself on the table, such as, for example, emotional well-being and emotional well-being. They intercept each other here, and they will have a perfect correlation. Like the whole point over here is that you cannot really measure a variable against itself if it's the same thing. So therefore, researchers don't enter those correlation coefficients into the matrix. So they just usually put a dash there, or sometimes what they will do is they will put the Cronbach alpha coefficient of the tool that they use to measure, for example, job resources. They'll put the Cronbach alpha coefficient in the place where the two variables intercept each other on the correlation matrix. Now the Cronbach alpha coefficient, we'll get to that later though, that indicates the reliability or the internal consistency of the tool that we use to measure, for example, job resources. Now, I believe that the Cronbach alpha coefficient must be at least 0.7. So let's say the tool that we use to measure job resources had a Cronbach alpha coefficient of 0.8. Then sometimes what the researchers will do is, like I said, they put the Cronbach alpha coefficient over there, well, the Cronbach alpha coefficient of the tool that they use to measure the variable of interest. In this case, it would be job resources. Okay, so, but that's not always the case. So, like one of the golden rules when you look at a table, before you start interpreting its results or what it presents, first look at the sub-comments. So, okay. Now, since these values, like we said over here, they just mirror images of each other, often what people do is, in an article, researchers, what they do is they eliminate the top half of the table in terms of correlation coefficients, because those values are presented at the bottom half of the table. Okay, so over here, So what they'll often do is that then they just, they remove the top half of the correlation coefficients. Another thing that they often do is instead of writing the full terms such as job resources, job satisfaction, and all of that at the top, they will just replace it with a number to refer to the variable that they're measuring. So for example, excuse me, that's supposed to be a 1. So let's say over here we label job resources as number 1, job satisfaction is number 2, emotional well-being is number 3, burnout is number 4. So imagine how much space it would take if a person had to write the full name of the variable at the top beyond this. So like I say, to save space, that can be one of the reasons. But to save space, what they'll often do is they just put the number that they use to refer to the variable. They'll put that number in the column at the top over here as I'm doing. So for example, okay, over here, which variable is labeled as number 1? Okay, it's job resources. So therefore, at the column over here that's labeled number 1, in that case we're referring to job resources. So for example, let's go to job satisfaction. Okay, go to excuse me, I'm just trying to think on my feet over here. Okay,